There's something NASA isn't telling you about 3I Atlas, and after December 19th, they're hoping you'll just forget about it, because on that date, this interstellar visitor will make its closest approach to Earth, and then it's going to fade, it's going to disappear. And all the impossible things it's been doing, they'll just become footnotes in scientific papers that nobody reads. But before that happens, I need to show you what's actually going on, because the latest data from December 10th just revealed something that breaks every rule of physics we know about comets. So in this video, I'll break down the anomaly that NASA hopes you'll ignore after December, because once this thing is gone, the questions it raised will be buried. Let's start with the most disturbing fact about 3I Atlas. This object is losing more mass than it actually weighs. Scientists have calculated that 3I Atlas is ejecting about 50 billion tons of material per month. That's based on how bright the tails are and how much gas and dust must be there to create that brightness. But here's the problem. The entire object only weighs about 33 billion tons, so it's losing 50 billion tons per month when it only weighs 33 billion tons total. That's physically impossible for a solid object. Now, we've seen this before. Comet Shoemaker-Levy 9 broke apart in 1992 and released way more material than the original comet should have weighed. But that made sense once we realized it had fragmented into 21 different pieces. More pieces means more surface area. More surface area means more ice can sublimate. More sublimation means more visible material being released. So when scientists saw 3I Atlas doing the same thing, they assumed it must have broken apart. The math said it should have fragmented into at least 16 pieces, but on November 11th, two astronomers, David Jewett and Jane Liu, published a paper with a very simple title, 3I Atlas Still Single. They observed a region around the comet that was 500,000 kilometers wide. They used multiple image processing techniques. They looked for any signs of fragmentation, and they found nothing. One single bright nucleus, no fragments, no debris field, no spreading pieces. So we have an object that's losing more mass than it weighs, but it's not breaking apart. That shouldn't be possible. Now, on December 10th, just yesterday, NASA released data that makes this even more bizarre. The Atacama Large Millimeter Array, or ALMA, analyzed the chemical composition of the gas coming off 3I Atlas. And what they found is being called the key ingredients for life. Specifically, they detected methanol and hydrogen cyanide. Now, finding these molecules in a comet isn't unusual, but the amounts are. Methanol makes up about 8% of all the vapor streaming from 3I Atlas. That's roughly 4 times higher than typical solar system comets. And hydrogen cyanide is also unusually abundant. This molecule can participate in chemical pathways that build amino acids and nuclear bases in laboratory experiments. So this interstellar visitor is unusually rich in the exact molecules that scientists think could seed young planets with organic chemistry, the building blocks that could eventually lead to life. But here's what NASA isn't emphasizing. These molecules appear both in the icy nucleus and in the extended coma. That implies active chemistry is happening inside the comet and in the gas flowing off it. Normal comets don't show this kind of complex internal chemistry. The ice sublimates, the molecules escape, and that's it. But 3I Atlas seems to have ongoing chemical reactions happening as the material is being released. And when you combine that with the impossible mass loss, you start to see a pattern. This object is doing things that shouldn't be happening naturally. Now let's talk about what's causing all this material to be ejected, because the latest research suggests 3I Atlas might be erupting in ice volcanoes. Scientists using the Jono Ro telescope in Spain reported evidence of cryovolcanism. These are volcanic eruptions, but instead of molten rock, they're ejecting ice, gas, and dust. The researchers found spiral jets of material rising from the comet. These jets suggest sudden, violent eruptions rather than steady sublimation. Here's how this would work. As sunlight heats the surface, it doesn't just warm the ice on top. It penetrates deeper, heating buried pockets of volatile ices. When the pressure builds up enough, those pockets explode, blasting material into space. This is different from normal comet activity, where the sun just heats the surface and ice gradually sublimates. Cryovolcanism is more violent, more sudden, and more energetic. And here's the disturbing part. The research suggests 3I Atlas may lack a thick, insulating dust mantle that most comets have. Without that protective layer, large regions of the surface can switch on at once when heated. That would explain the global surge in activity. That would explain the multiple jets. 7 or 8 have been observed, and that would explain how it's ejecting so much material. But it still doesn't explain how the object is staying intact while losing more mass than it weighs. Now, in November, scientists achieved something that's never been done before. They detected the first radio signal from an interstellar comet. Using the Meerkat radio telescope in South Africa, astronomers picked up emissions from hydroxyl radicals, OH molecules, produced when sunlight breaks apart water molecules in the coma. This isn't a technological signal. It's a natural spectral signature. But it's significant because it's the first time we've detected radio emissions from an object that came from another star system. And then, just recently, scientists reported the first X-ray detection of an interstellar comet. The Japanese X-RISM Observatory detected a faint X-ray glow extending 400,000 kilometers from the nucleus. That's roughly the distance from Earth to the Moon. This X-ray halo is absolutely massive. The X-rays are thought to come from charge exchange reactions between the solar wind and the gas cloud around 3I Atlas. This is a known process that's been observed in solar system comets. But here's what's interesting. The X-ray glow is unusually extended and bright for a comet this far from the Sun. It suggests the gas cloud is much larger and denser than expected, which brings us back to the same question. How is this object producing so much gas? If you've seen images of 3I Atlas, you've probably noticed it glows bright green. This isn't unusual for comets. The green color comes from diatomic carbon, C2 molecules, that fluoresce when hit by sunlight. But what is unusual is the anti-tail. Most comet tails point away from the sun because solar wind pushes gas and dust outward. But 3I Atlas has a tail pointing toward the sun. At times, the comet seemed to lose its tail entirely, in images that showed only a bright head. Later analysis revealed the tail was pointing almost directly away from Earth, effectively hidden behind the coma. But the anti-tail has been persistent. It's been observed for months. And it's not just a viewing angle trick. Harvard astrophysicist Avi Loeb has suggested this could be a swarm of objects that separated from the nucleus and are now traveling ahead of it, closer to the Sun. His calculations predicted they would be about 60,000 kilometers ahead by late November, and the Hubble images from November 30th show an anti-tail extension of about 60,000 kilometers. The prediction matches the observation. If Loeb is correct, then 3I Atlas isn't just one object. It's a nucleus surrounded by a cloud of fragments, and that cloud has way more surface area than the nucleus alone, which would explain the extreme brightness and mass loss. So here's why December 19th matters so much. On that date, 3I Atlas will make its closest approach to Earth at a distance of 1.8 astronomical units. That's about 170 million miles, or 270 million kilometers. NASA has been very clear. This poses zero danger. It's not going to hit us. It's not even going to come close by planetary defense standards. But December 19th is our best observation window. From now through mid-December, 3I Atlas is in the most favorable position for telescopes to study it. Right now, it's around magnitude 10. That's far below naked eye visibility. You need a telescope with at least a 12-inch aperture to see it as more than a faint smudge. Professional observatories around the world are pointing their instruments at it right now. They're measuring its brightness, analyzing its composition, tracking its jets, looking for any signs of change. Spectroscopy will reveal what molecules are being released. Photometry will track brightness variations. High-resolution imaging will search for fragments or structural changes. All of this data will be compiled over the coming weeks and months, and it will help answer the fundamental questions. How is this object staying intact? What's causing the anomalous mass loss? And what can it teach us about planetary systems beyond our own? But after December 19th, 3I Atlas will start to fade. It will continue outward, passing within 0.36 AU of Jupiter in March 2026, and then it's gone forever. By spring 2026, it will be too faint for most telescopes, and the window will close. So here's what NASA hopes you'll ignore after December. They're presenting 3i Atlas as just another comet. Unusual, yes. Interesting, sure. But ultimately natural and explainable. They've explicitly stated 3i Atlas is a comet, not evidence of aliens. They've released multi-mission imagery to back up that conclusion. They've emphasized that everything observed is consistent with natural processes. And to be fair, they're probably right. This is most likely a natural object, but that doesn't mean it's not anomalous. Because here are the facts they're not emphasizing. 1. It's losing more mass than it weighs, yet staying intact. 2. It has unusually high concentrations of methanol and hydrogen cyanide, the ingredients for life. 3. It shows evidence of cryovolcanism, ice volcanoes erupting across its surface. 4. It's the first interstellar object to emit detectable radio signals. 5. It's the first interstellar object to emit detectable X-rays, with an unusually large and bright halo. 6. It has a persistent anti-tail that may be a swarm of fragments, matching Avi Loeb's precise predictions. 7. It's 7 to 10 billion years old, nearly twice the age of Earth, and carries chemistry from an era before our solar system existed. Each of these individually could be explained. But all of them together, that's a pattern. That's something genuinely unusual. And after December 19th, when 3i Atlas fades and disappears, NASA will move on, the news cycle will move on, and all of these anomalies will just become data points in scientific papers. So, here we are. December 10th, 2025. 9 days until 3i Atlas makes its closest approach to Earth. This interstellar visitor has been doing impossible things, losing more mass than it weighs, erupting in ice volcanoes, glowing in X-rays and radio waves, carrying unusually high concentrations of life's chemical ingredients, and in just over a week it will reach its closest point to us. That's our last good chance to study it before it fades into the distance. After that, it will pass by Jupiter in March 2026. And then it's gone, back into the void between stars, never to return. NASA will publish papers, scientists will analyze data for years, but the public attention will fade, the questions will be forgotten, and 3i Atlas will become just another footnote in astronomical history. But it shouldn't be, because this object is teaching us that the universe is stranger than we thought, that comets from other star systems don't follow our rules, that chemistry billions of years older than Earth can still surprise us. The anomaly NASA hopes you'll ignore after December is this: we don't understand 3i Atlas. We can't explain how it's doing what it's doing, and we may never get another chance to study an object like this in our lifetimes, so pay attention now. Because after December 19th, the window closes, the comet fades, and the anomaly gets buried. But the questions it raised, those will remain, and they'll haunt us long after 3i Atlas has disappeared into the darkness between stars. If you watch to the end, drop me a like and subscribe for more updates. If you want to learn more about the other mysteries surrounding 3i Atlas, check out this video where I break down Avi Loeb's swarm hypothesis and the evidence for fragments. Thanks for watching, and I'll see you in the next one.